Are you around?
Yeah.
Yes.
Okay, let me check.
Yes, sir.
Continue.
I wanted to admit other new students. So they are still coming. Okay. Do you see? Please, what are you doing? So do you see that screen? Sepe? Sepe?
Yes, yes.
Do you see that slide?
Yes. The definition notation.
Is it okay? No problem.
Yes, yes. No problem.
But there are other students. The students who are present are also seen. You see them? Or
Yes.
no, it
Yes,
is not
sir.
okay. I don't want that they appear here. And even I cannot. Okay, for the moment, I'm going to stop sharing and then I'm going to restart again sharing. Okay? Yeah, sharing here. Here is.
Yes.
Okay, now this is okay. Yeah, after around maybe 5 minutes, I'm going back to admit the new ones. So I was talking about the definitions and notations. So that time we talked, if I remember, what we mean by raw data. The raw data in statistics are those data which are collected in their original form. For instance, when one wants to study the performance of the students, it is just to go to the department and make a request for having access to those data. So this is what we call the raw data. It is about those data which are not yet worked on it, on just how we get them. Last time, I told you that in the National Institute of Statistics, they have so many data which are kept in the soft copy form. So if you go there and you request something, some data, they will give you those soft copies and how they look like. You can work with them. So this is what we call the raw data in statistics. So a variable will be denoted by capital letters such as X and Y, Z, etc., and the corresponding values. Their corresponding values will be represented in small letters, X1, X2, or Y1, Y2, etc. So now, the next is to speak about the frequency. So what do we mean by frequency in statistics, specifically here in the descriptive statistics? It is the number of times a kind of value or a certain value or class of values occurs in the list of those raw data. So we denote it by small fi, and the frequency of any small xi, and the sum of all those fi's gives you the size of the sample. So to mean that what we said the last time about the sample, it means that the subset of population which is chosen, and the elements of it should be started. And from that sample, we collected the data, and then if we wish to know the size of the sample, I mean how many elements we get from the sample, it is that small n. So this is, so it is that small n, which is equal to the sum of those frequencies. So fi, that I is varying from 1 up to that n. So this is, then one can speak about what we call relative frequency, which is actually, in other words, is the proportion of what? Proportion of a given frequency, which is divided by the total number of elements, or divided by the size of the sample. And here is how it is denoted, that capital R Fi. So relative frequency, that R stands for relative, and small f stands for frequency. Then another concept which is used in descriptive statistics is what we call cumulative frequencies. This is running the total sum of the frequencies, and here is how it is obtained. So that the cumulative, that C stands for cumulative. As you know, the small f stands for, that small f stands for frequency. And if you wish to have the cumulative frequency, it is the sum of those frequencies, simple frequencies, fk, whereby k starts from 1 up to I. And this is what we call cumulative frequency. We are going to see it below in the table. Another concept is the frequency distribution table, which is a table that summarizes the data collected. And here we have a table which is called the frequency distribution table. So as you can see here, in the first column, we have the values of the variable. So for each variable, we get the values. Those values are those data which we collect from the chosen sample. So that xi's, x1, x2, xp, etc. Then for each value, you get the frequency. So how many times that xi appears in the list. of data, those data which you collect from the sample. And then for each xi, say x1 for instance, you can have what we call the cumulative frequency of, which is symbolized by small f1. So this can be done then for all elements, for all data, xi's, x2, you get its corresponding frequency, f2, and it can be possible to have the cumulative frequency for it. So the same can be done for the last element, xp, and its corresponding frequency to mean that how many times that number xp appears in the list. And you can, of course, using that formula which is shown here in the previous slide, have its cumulative frequency, which is equal to the sum of fk. So this is how we can construct what we call the frequency distribution table. So allow me then go back to see those ones who needed to be admitted again. Some of the yeah, and then in order to come back, yeah, then I admitted them. Okay, now here you have an example of what? Of what we call raw data here. And I want to look at how we can make what we call that frequency distribution table. Yes, go ahead, please. Go ahead.
Question.
Yeah.
Hello? There are some students who are telling me that they are still on they asked to join, but you never admitted them.
Yeah, I'm going to do it. Are they admitted? Are they? So far I have 21. Yeah, including me. So it means 20 students. Are they admitted? So are you still seeing the screen?
No.
It disappeared. So allow me again to share again. Okay, you can see it now. Right?
No. No.
Yes.
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 It's supposed to be seen. Can you see it?
Yes.
Can you?
Yes.
Yes, you see it.
Yeah, I'm talking about how to construct that frequency distribution table. Here we have an example. The following data represent the number of days of sick leave taken by each of 50 workers of a given company over last 2 months of the year. So the word year is missing here. The year. So if you count, then you are going to see that there are about 50 workers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 25, the first row. So definitely the second one also is 25. 25 times 2, it makes 50. Now, with this is what I told you that this is what we call the raw data. You can see it? Hello, class? Class?
Yes. Yes.
Hello.
That is table of raw data.
Hello.
Yes?
Yes.
Okay, now this is what we call raw data because, for instance, it starts with number 2, 0, 0, 5, 8, 3, etc. So it is hard to get any information from how those data look like. So this is what we call raw data. But then, by doing what we call the frequency distribution table, we are going to see that if we try to interpret that table, we will get some information. So they say construct the frequency distribution table for this data set. Number 2, use the table for sub-question 1 to answer the following questions. How many workers had at least 1 day of sick leave? How many workers had between 3 and 5 days of sick leave? How many workers had more than 5 days of sick leave? Find the proportion of workers that had no sick leave. So by answering those questions, the answer for them, they should be observed from that what we call the frequency distribution table. And here is the table. So remember what we said, what we call values. Values. If you check here, go back to those raw data, there is number 2, there is 0, there is 5, there is 8, there is 3, there is 4, there is 1, there is 7, 9, and that's all. So those are what we call XIs, values. But that value XI can appear many times in the list. To mean that, for instance, you have number 0, the value of the variable, number of sick leaves. Number of sick leaves. It means that 0, it means the 12 workers did not get sick during those 2 months. So that is why the number of sick leave is equal to 0 for them. How many workers? 12 workers. Now, if we go to the number 1, how many workers got sick during that fixed period of time? So 8 workers, they got sick just 1 time. 5 workers, they got sick 2 times. 4 workers, they got sick 3 times. 5 workers got sick 4 times. 8 workers got sick 5 times. 5 workers got sick 7 times. 7 times, etc., 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 etc. So this is how we can answer the first question. See, this is the value, its frequency. And then to answer, the answer is the sum of the, okay. I've got to say something which was found on this slide. Yeah, allow me again to see if there are still some students who wish to get admitted here. Yeah, they are admitted. But then this exercise requires me to stop first sharing and restart again to sharing. Yeah. So this is now I'm going to share the window. So I hope now you can see the slide. Class,
Yes.
Yes, you see.
you can see the slide. Now
Yes.
using that table here for the sub question 1, we have the following results. Say, since 12 of 50 among 50 workers had no days of sick leave, the answer is that 50 minus 12 is equal to 38. So what was the question here? The question was use table for sub question 1 to answer the following questions. How many workers had at least 1 day of sick leave? At least 1 day of sick leave. You must be very thankful because the question says, how many workers had at least 1 day of sick leave? So then what is the answer for that question? They say since 12 of the 50 workers had no sick leave days, they had no days of sick leave. So the answer is that it means that the only 12 worked all days without being sick. So therefore, we are going to take the total number of workers, which we can call the sample size. Sample size, we are told that there are about 50 workers. So that number 50 is what we call the size of the sample. And now, according to this table, from this table exactly, we say that among those 50 workers, only 12 did not get sick. So the rest of the workers, they have got sick leave. So they say since 12 among of the 50 had no days of sick leave, the answer is that 50 minus 12, which is 38. The answer is the sum of the frequencies for value 3, 4, 5, and that is 5 plus 5, 4 plus 5 plus 8, which makes 17. Yeah, let me see the next question. How many workers had between 3 and 5 days of sick leave? How many workers had between 3 and 5 days of sick leave? And if we go here for that question, we say between 3 and 5, 3, 4, and 5. 3, 3, 4, and 5. You see me, you see what I'm showing on the table here? 3, you can see it? Class?
Yes, we
3,
can see it.
3, 4, 5. So they say it take 4 plus 5 plus 8, which makes 17 sick leaves. You understand the answer here? Yeah, I repeat the question. How many workers had between 3 and 5 days of sick leave? Then the answer is the following. Since 12, the answer is the sum of the frequencies for values 3, 4, and 5. Then we get 5 plus 4 plus 8, which makes 17. Next question is, how many workers had more than 5 days of sick leave? More than 5 days of sick leave. How many workers had more than 5 days of sick leave? Here we are talking about the workers, not the sick leaves. The sick leaves. So how many workers had more than 5 days? More than 5 days. So we count from 8, from more than 5 days. We count 7 more than 5 days. So we count 5 plus 2 plus 1. Let us, here is, the answer is that the sum of frequencies for the value 6, 7, 8, and 9. So we say, therefore, the answer is 0 plus 5 plus 2 plus 1, which makes 8 workers. Now, the next question was, find the proportion of workers that had no sick leave. The proportion of workers who had no sick leave. So you remember, if you go to the table here, how many people who did not have any kind of sick leave? They are about those ones who have the number 0 here. So they are about 12. Now, the proportion here is to take 12 over 50. Yeah, but better to make it in percentage. And you take 12 over 50 times 100, and you get 24%. So you can see how we can get the information from that frequency distribution table. That distribution table, as you know, it came from the raw data here in the previous slide. So by trying to summarize those data in the raw form, then we summarize them in that frequency distribution table. And from that table, definitely we can get very good, interesting information. Now, after this, the previous paragraph was about the frequency distribution. Now, the next paragraph, we are going to talk about the data presentation for ungrouped data. Data presentation for ungrouped data. Yeah, corrected data can be represented by using a diagram, so to make some reports. For example, we do what we call bar charts, we do what we call pie charts, and there are other kinds, but mostly likely in statistics, they like to use the bar charts and the pie charts. This is seen in different medias, for instance, in different journals and documents. They use bar charts and the pie charts. And as I said on the beginning, the descriptive statistics allows us to get some information from the different type of representing the data. So the first one was the table, which we call the distribution, frequency distribution table. And now another kind of way of presenting the data is to represent them by the diagrams, such as the bar chart and the pie chart. So what we call bar graph or bar charts. Bar chart may be total or component bar charts. It is a total when a data that can be divided into cluster is taking a single and consider as one. On the other hand, when the data is considered as an individual cluster and treated individually. So the example here is if one considering the population of a community, if population of the male and the female were added together, that is total. But if the population is considered as male and the female individually, any chart we draw with this partial data is component. So let us see an example. Given the table below, which represent the number of foreigners living in the provincial area of Rwanda in this year of 2006. So you see, those are different countries from where those foreigners came from. And you see, there is country, yeah, country, then how many people came from that country, and what is I can call the relative frequency of it. So again, this is a table which apparently look almost similar to that one. What is added here is that column of relative frequency for each value. What I can say here, it means that the variable here is the number of foreigners living in Rwanda and from which country they came from. So the variable here is which foreign country they came from. There is the United States, there is Japan, there is Europe, there is Korean, there is, none of them. So it means that they came from other countries than those four. So you raise a question? Question? Class? Hello? Class? The slide disappeared, or you are still seeing it? You see it? But it becomes smaller. The same size? Okay, I was trying to admit the other students who were not yet admitted. But apparently I don't see the participation. In total, I have 21 students. Where are the others? Huh? Sepe? 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 So he has a problem of connectivity. Okay. So what is the problem? Maybe other students, they did not have the access to be connected.
Yes.
Because,
Hello?
yeah, Sepe. So I have only 21 students. And on the list here, that time when I had a face-to-face, I had about 54. So I'm not happy with that. Yes.
Some of them they use
They are using what?
phone, maybe. Hello?
Hello. Yeah, just a minute. Just a minute. Thank you very much. Hey. Hello. Class. Hello,
Yes.
class.
Hello. Hello.
Yes.
So what is wrong with other students? You don't have any idea. Okay, allow me to for the moment to stop and see how many are they.
Yes. Yes.
Yeah, for instance, I have uh, Donisio Studio, the name I don't know. Joseph Biringiro, and 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 that's all. So then I'm going to make the attendance today. And I'm going to report it to your HOD. So how do you think? Huh? What do you say?
Someone don't have access to internet.
You don't have. They don't have.
Yes, they don't have access.
Yes.
So, CP, this must be reported to your HOD that the attendance is very slow. Right? Hmm? Okay. Now let us again continue.
Even some are using YouTube.
Some of them are using YouTube.
Yes,
They are following.
on YouTube.
They are following on the YouTube.
No.
Huh?
Yeah.
Is
Yes.
it possible?
Yes, it is possible.
But I cannot see them if they are following or not attending. How I can check them?
We are using the link on Google.
Yes, this is what I did. I send it to all. So I use that class email. So it is where you have got the link, of course, right? Is it? And then the Okay, we now going to share again the slide. Okay.